I want to talk to you a little bit about experimental design. Then we're going to talk about a few other items that we might take into account with experimental design. And then at the end of the lesson this week, we'll talk about an actual designing an actual experiment. So experimental design has four basic principles. One is control. So what we're trying to do is we're trying to control as much as we possibly can. The more things that are not controlled, the more doubt we have as to whether or not changing one factor actually had an effect on the response variable. So again, we're trying to control everything that we are not studying. So control all of the things that are not being studied so that we can look at the effect of what we are studying. Number two, randomization. Obviously, we are trying to randomly assign subjects to the treatment levels. Otherwise, there is a bias due to uncontrolled sources of variation. So we want to randomly assign. Step three, or principle three, is to replicate. So we want to create experiments that can be replicated easily. The reason that we do this is because we want to make sure that our results are indicative of what should actually happen. So if I have certain results and then someone else replicates my experiment and has much different results, then I might question my own results and whether or not they are accurate. And blocking. So sometimes we use blocking or grouping similar individuals together and then randomizing within those blocks, and it can help us account for some variability. So I'll show you reasons why we might do that. Again, blocking is not necessary, it's optional based on whatever situation you have. So again, this is a preview to designing an experiment. We're trying to test if pet food is safe. So the control would be everything that we're trying to control. So things that we might try to control here, food portions. So we're testing if pet food is safe. Let's make sure that one dog isn't eating a cup and another dog eating 3 cups and therefore vomiting because they ate too much food. Water portions, housing, exercise, sleep, breed. So all of these things we would want to control so that the things that we could actually test is if the pet food itself is safe. What are we going to randomize? We're going to randomly assign dogs to 2 feed treatments and then replicate. We can redo the entire experiment with a different breed. So let's say I'm choosing whatever certain breed I want to start with. So my random allocation puts dogs into group 1 or group 2. Notice that I'm specifying that it's random. Then we're going to apply treatment 1, which would be, say, using pet food 1, and then treatment 2 would maybe be pet food 2, and then we're going to compare whatever it is, however we're going to measure. And again, this is just a preview, so it's not as detailed as what we will get to in just a little bit. But this is an idea of how we do this. So we start with a certain group. This would be however many dogs we start with. We break them into groups, we apply the treatment, and then we're comparing results at the end. At the end, of course, we want to analyze our results. So we would expect our results to vary some. We talked about that sampling variability or sampling error. That's normal and natural. What we want to know is at what point is the difference statistically significant? So the difference between the pet food 1 and pet food 2, etc. What can we say happened because of chance, because of different samples, and what can we say happened because there is a difference? And that means that we want something that's statistically significant. For now, we're just using our judgments because we haven't really decided what's statistically significant. We haven't learned enough about statistics yet to know that. So for now, we're using the tools that we already have in our statistical toolbox, which is, hey, let's make some box plots or some histograms, or let's compare means or medians, etc. So these are things that we can do for now. Later, we'll learn actual statistical methods for comparing. So example, we expect about 50 heads with 100 flips of a coin. I wouldn't be surprised if I got 52 heads, but if I got 92 heads, I would think I was dealing with an unfair coin. The question is, at what point in between 52 and 92 would I start saying, I'm not sure that this is a fair coin? So again, that's just up to judgment for now. Later on, we'll learn how to, put some numbers into that. This would be a good way to compare 2 distributions, since this is something we know how to do. If I made 2 box plots of our data, looking at this, I would say whatever I'm measuring, and it's not clear what I'm measuring, but whatever I'm measuring, this would be statistically significant because as I can see, this whole middle 50% of data is above 75% of the data from the other group. So I would say whatever it is I'm measuring, whatever I did in the experiment on, that it definitely made a difference in whatever I was measuring. Before we continue, I want to see if you can answer the following questions about this experiment. So at one time, a method called gastric freezing was used to treat people with peptic ulcers. An inflatable bladder was inserted down the esophagus and into the stomach, and a cold liquid was pumped into the bladder. And that just sounds horrible and excruciating. Now, the insurance company put a notice on their website that says, we do not cover gastric freezing for chronic peptic ulcer disease. Gastric freezing for chronic peptic ulcer disease is a non-surgical treatment which was popular about 20 years ago, but is now seldom performed. It has been abandoned due to a high complication rate, only temporary improvement experienced by patients, and a lack of effectiveness when tested by controlled clinical trials. So my question is, what did that clinical trial probably look like? What are the factors, response variable, and treatment? And how did the researchers decide which subject received which treatment? And were the results statistically significant? So press pause, see if you can answer those questions, and then press play to check your work. So let's look at these together. What do we think that controlled clinical trial probably looked like? Well, I'm hoping that they took people and randomly assigned people who had peptic ulcers and randomly assigned them to either the gastric freezing group or whatever the alternative treatment is, which is what I'm assuming people are still using today. Then they would perform that surgery. And again, what are we trying to decide? We're looking for improvement of some sort of the peptic ulcer. So I'm not sure exactly how that was measured. That information isn't given in this short little blurb. So what is the factor or factors? Well, the factor would be the treatment of the peptic ulcer. So either gastric freezing or the alternative, but that is the factor, is the treatment. The response variable is the improvement. So however they're measuring that improvement, but that is the response variable, is the healing of that ulcer. The treatment is either gastric freezing or the alternative. How did researchers decide which subject received which treatment? We have no idea. We're assuming that it was chosen randomly, but that information is not given here. Were the results statistically significant? Well, obviously not, because we can see the results here say that they're not going to cover it anymore. So if the results were statistically significant, meaning that treatment of peptic ulcers with gastric freezing was beneficial, then they would still cover it, because then their patients would be doing better